Thank you. So our next speaker is local, Mr. Victor Cheung. He's the president of the Hong Kong Institution of Engineers, and he's going to talk to us about building services designed for high-performance green hospitals and healthcare facilities. So, Victor.
Good afternoon, ladies and gentlemen. I'm going to share with you in the next 20 minutes some local experience about building services designed for hospitals. Hospitals are for treatment and caring of patients, and therefore the comfort and well-being of patients, the staff working in it, and also the visitors is a prime objective of every engineer, architects, and operator. But hospitals require complex but reliable building services systems to support their 24/7 operation throughout the year. Because they actually consume a lot of energy, so we must actually put environmental responsibility on a very high agenda. Successful high-performance hospital projects require an integrated approach involving close collaboration amongst architects, building services engineers, the user and operator to achieve an optimal design with the least overall project cost. The building envelope design and the performance of building services systems are the key elements of high-performance hospitals. How the building service systems are designed and installed affects how efficiently they perform. So a well-defined operator's requirement from the users is crucial to form the basis of design, as it can ensure the building services systems are properly sized to meet the requirements while achieving low capital costs and high energy saving. So a clear and concise performance brief from the operator will also ensure that reliable and efficient building services systems are provided so that the operator can operate them and maintain them year by year. Now, the architect and building services engineer can also work together to optimize the design of the building envelope to maximize its thermal performance, such as the building shape, volume, and orientation will have an impact on daylighting, on solar heat gain, and also heat loss and energy consumption. We should be using building materials with low U value and emissivity for the opaque envelope components, such as the walls and roofs, and minimize the amount of glazing and select glass with low U value and solar heat gain coefficient. Provide external shading devices such as fins and overhangs. But a proper balance is required amongst the visual performance, maximizing daylighting, and also minimizing solar heat gain and heat losses through the windows. A well-designed and constructed building that is reasonably airtight can minimize the infiltration of hot air into the inside from the outside. So green roofs can also reduce the heat gain from the sun and the urban heat island effect. Dr. Guan already has shared with us some of the design principles that he has taken for his architectural design of hospitals earlier on. Now, building services systems play a very important role, not only in controlling the desirable space temperature and humidity, but also maintaining good indoor air quality and the relative pressure between spaces for proper control of transmission of airborne diseases and contaminants. So building services systems for hospitals must fulfill 5 very principal design criteria. They are service continuity, comfort, infection control, indoor air quality, and energy efficiency. Energy represents the 3rd largest cost in healthcare services, behind staff wages and medicines. According to a figure given by Chief Executive of the Hospital Authority, Dr. Leung Pak-yin, the total electricity bill of public hospitals and healthcare facilities in Hong Kong is somewhat like 800 million per annum. So HVAC system and hot water systems are the major energy consumers, followed by lighting, lifts and escalators, and medical treatment equipment. As the hospital operates 24 hours a day, year-round, improving energy efficiency is the fundamental requirement for high-performance green hospitals for building services engineers. There are several ways to reduce the energy consumption of HVAC systems. First of all, a well-designed building envelope can minimize the solar and thermal heat gain, and therefore reducing the need for air conditioning at source. Then we can look into the HVAC equipment efficiency. The central chiller plant should be selected based on not only the COP, which is the efficiency under full load condition, but also part load performance, as these plants, they rarely operate at full load. So therefore, a high integrated part load value, the IPLV, should be specified. Also, oil-free chillers and variable speed chillers, they have very good part load efficiencies, and they are becoming more affordable nowadays. Now, conventionally, central chiller plants are designed with primary and secondary circuits where the primary pumps provide variable flow to the building, and primary pumps maintain a near constant water flow through the chillers. Now, modern chiller design make the variable water flow through the evaporators possible with a variable flow chill water system. So the system can actually reduce the installation and operating costs because one group of chill water pumps is eliminated. Further cost reduction in pump energy can also be realized by adopting a wider chill water delta T. Multi-zone VAV air handling systems, they are normally used together with the primary air handling systems for hospitals. The cooling and dehumidification of the internal space, they are normally done by the AHU, while the cooling and dehumidification of the outside air is being handled by the primary air units. Demand control ventilation strategy using CO2 sensors to control the outside air supply rates can be adopted for large space that are densely populated, but with a widely varying pattern of occupancy, such as open plan office and also conference room. And the supply air temperature reset during non-peak weather months and also unoccupied period can substantially reduce the air conditioning load. Hospital also requires a large amount of outside air to maintain a very high air change rate for acceptable indoor air quality and offset the exhaust air in order to maintain building pressure. The high humidity and temperature of Hong Kong weather impose a tremendous cooling load in conditioning the outside air. Exhaust air recovery, energy recovery, is an effective way to recoup cool energy in the exhaust air to pre-cool the outside air to reduce the cooling load. But a centralized exhaust is not always possible in hospitals because rooms requiring exhaust are numerous and they spread all over the building. Also, not all the exhausts are suitable for recovery because those from the labs and fume hoods, they have to be discharged directly to outside. So care should also be taken to prevent cross-contamination of dirty exhaust air to the clean air side. So this can be eliminated by purge cycle and also ensuring the intake pressure is always higher than the exhaust pressure. In the past, hospitals used steam to provide domestic hot water and hot water for space heating. Now this is very costly because energy conversion is very inefficient. A more energy efficient way is to use a dedicated steam boiler for sterilization and then a high efficiency gas-fired water heater for domestic hot water. A water-to-water heat pump can also recover energy from the condenser water circuit rejected from the central chiller plant to generate low-grade hot water for space heating and also terminal reheat for humidity control. Solar hot water system is also a worthy investment of renewable energy technology for hospitals because of the high water demand. And normally, we can actually achieve a payback period of 2 to 3 years. Solar energy can also be used to provide cooling. Solar cooling system, they use thermal solar collectors to provide heat energy to drive the absorption chiller that produce chill water for air conditioning. But despite the COP of absorption chiller being very, very low, less than unity, the energy is actually free of charge. As I mentioned before, lighting accounts for 18% of electricity use in hospitals. T5 fluorescent lamps and also with electronic bollards and also compact fluorescent lamps have already replaced the old T8 fluorescent lamps and incandescent lamps. But with the improved quality and lower cost of LED lamps, they are becoming the preferred lighting solution to reduce the lighting power density because of their superior performance and longer service life. Lighting control using occupancy sensors for rooms that are not in use, although they are not preferred by Dr. Long earlier on, as he mentioned, and also using dimmers for daylight harvesting control can help further reduce energy consumption of lighting installations. Less waste heat from the lighting installation means lower cooling load to handle by the HVAC systems. Hospitals also require efficient movement of people and also delivery of materials. Lift and escalators, as I mentioned earlier, they consume about 2% of electricity in hospitals. So there is a great potential to reduce energy use of the vertical transportation systems, including the use of regenerative technology for the lifts. We can turn off the lift car lighting and ventilation fans when the lifts are not occupied, and we can slow down the escalator speed when it's not in use. Hospitals consume huge amount of water. To reduce water consumption, we can use low-flow fixtures and sinks for sinks and showers, sensor control taps for urinals, and then dual flush WCs. Minimizing dead leaks in the hot water recirculation loop can also reduce the time for the hot water to reach the tap, but also reduce the risk of Legionnaire's disease, as Dr. Long mentioned earlier on. Rainwater could be harvested for irrigation of soft landscape to reduce the use of fresh water. A building management system with direct digital control will provide comprehensive control and monitoring of the building services systems, but adequate provision of metering is required. Energy dashboards provide instantaneous energy use information to facilitate the operator to optimize energy efficiency. Commissioning not only ensures the building services system perform properly according to the design, but also can help improve the building energy efficiency through fine-tuning of the set points and the control logics to suit the actual operational requirements during pre-occupancy and early post-occupancy periods. Just as your car requires to be tuned up periodically, hospitals, they're no difference. Hospitals are dynamic buildings that undergo constant changes during its lifetime to suit the operational requirements. So recommissioning should be carried out periodically so that systems can be recalibrated to maintain functional performance and improve energy efficiency. Trigeneration is most suitable for hospital application because there is a steady requirement for electricity, cooling, and heating. In a trigeneration system, waste heat is recovered from the power generating equipment to provide water heating, and an absorption chiller driven by the waste heat to provide chill water for air conditioning. Although system is quite common overseas, but is not actually used in Hong Kong because of our low electricity tariff. But trigeneration system, there is recently a trigeneration system being adopted locally, a pilot scheme being implemented in Netherso Hospital in Tai Po, using the methane gas recovered from adjacent landfill site in Da Gu Liang as fuel to produce electricity, domestic hot water, and chill water for air conditioning. Radiant cooling system with displacement ventilation have been used for hospital projects overseas. The system actually provides drafts-free air conditioning and reduces airborne transmitted contaminants, and is highly energy efficient. It also requires less ceiling space for installation. Radiant cooling system is not used in Hong Kong in the past because under the very high humidity weather in summer, we run the risk of condensation in the air-conditioned space. But situations changed. In recent years, there are several radiant cooling systems being used for offices very successfully and achieved superior energy saving. Perhaps it is time for us to explore the use of radiant cooling in our hospitals. Ladies and gentlemen, that's all for my sharing this afternoon. Thank you very much.